All right, so let's get this live stream started. Great to see a few people here today. It's kind of Christmassy kind of time now. I got school holidays in session now, so a little less regular with the kind of whole video schedule at the moment. Just taking little opportunistic moments to get some of these sessions in. But yeah, it's really nice to have the kids and everything at home as well at the moment. I just got this little medal from my 6-year-old today. Says I'm doing a good job, so it's nice to see. But anyways, enough about me. Today I wanted to go over there's a little bit of an update on a video that I posted on Monday. So I'm not too sure if you guys have seen that already. If you have, let me know. I don't know if you've downloaded the files as well. I started to have a little bit of a play with it. But anyway, today I thought I'd take the chance to go over some of the little updates that I've made to the file, just to help you guys understand that a little bit more. Now, if you watch the video that I posted on Monday, basically you would have seen this dashboard, which you can pretty much implement in about 10 seconds ago. So let me just come over to RStudio, and I'm just gonna start a new file. Type in my little shortcut here, hit tab, and this basically loads up my template. So you can see how fast this is to do this. Now, when I posted the last video, I was using built-in sample data sets like MPG and common things like that. So I wanted to do something which seemed like a little bit more realistic. So I wanted to load up a bigger data set. So I give an example using read CSV. You can basically load in a data set from your computer, right? And I've got this data set I have here, which has got 5 million records in it, right? Now, just for you guys on the live stream as well, I thought I'd take the chance to show you an additional little tip. The read CSV is part of tidyverse, and I don't know if you guys okay. So I don't know if everybody here is already using R and already using tidyverse for their analysis. So if you're not familiar, R has got a number of different standards, right? So you've got base R, which was developed over 20 years ago, and for those who are not familiar, R was originally a statistical programming language used to teach statistics, right? And since then, it's been upgraded, and we started to see it being used in industry a lot more. And that's called for the need for certain standards to develop, like the tidyverse standard. Right. Okay. And so read CSV is part of the tidyverse standard. Now, in between tidyverse and base R, there was there's another kind of library as well, which is quite a powerful library, and that's a library called data tables. Now, I've only just very, very briefly mentioned this in previous videos before about the best ways to load up data in R. And the reason I haven't really talked about it is because, well, I've very much been trying to stick to the tidyverse standards, right? There's a lot of benefits in sticking to the tidyverse standards. And I think, that's probably a whole conversation in itself. But one of the benefits of data tables is that they're really fast, right? They're very good at loading up larger sets of data quite quickly, actually. So in fact, let me give you a little example here. So I'm going to do this system system.time, right? And this is basically just going to see how long it takes to say, let me just load the tidyverse library first, actually. Library tidyverse. Okay, and I'm going to go system.time and read CSV. And where's my 5 million records? So there we go, 5 million records. So that's going to go off and load. And you've got a little progress indicator here. It shows you all the different columns that it's loading in and the column types that are being loaded in as well. And so I think this takes about 12 seconds in total or so it's nearly done. And there we go. Okay, so it's taking 15 seconds. Every time I'm doing some sort of recording or streaming, this thing always takes longer because I think the recording takes up quite a bit of the processing and stuff as well. But there you go. So that takes about 15 seconds. Now let's try this using data tables instead. So instead of read.csv, I'm going to use data tables, data.tables, and fread. Okay, there we go. And let's run that. Oop. Okay, no package code data tables. What's going on there? Oh, data. Okay, that would help. Data table, not tables. And this is using the fread library. And that took 5 seconds. So this actually ran 3 times faster than the read CSV function in tidyverse. Now, so for larger data sets, this can actually work quite well. And it's a really quick, nice little hack, if you will, that will speed things up if you actually get to the point where things are slowing down. Now, one of the reasons why I haven't really taught this before is really because I think, when you start building out software and building out solutions, it's really an engineering problem, right? And so there's always these different trade-offs between different things. So if speed is one of your attributes, what is the trade-off for speed? And one of those trade-offs is stuff like interpretability, right? And different things like that. So, and this will load into a data table object. Now, the data table object and the tidyverse tibble object are effectively both data frames, right? But they're sort of enhanced versions of data frames. And if you're using tidyverse for like everything else that you do, then generally most of the time I would actually still use read CSV because it's a bit more compatible is the short answer. But anyway, don't want to digress too much with that. So anyway, here's my 5 million records, and I'm going to load it up here. Okay, and let's run that. So let's just call this demo.rmd. So RMD is a R markdown file, and I'm renaming it from an R file to an RMD file. So that's the little warning message. Okay. I actually forgot to type in fread in here. Let's try that again. And while that's loading, thanks for joining Wayne, and thanks for joining Julian. Great to see you coming in from Melbourne. What time is it there in Melbourne right now? Okay. So anyway, this is working off 5 million records here. And one of the little additions to the video that I posted on Monday is that I have this little number on the side here, right? And part of the session, I'm going to take a little bit more time to explain how this works. And this is going to be actually a little bit of a teaser into some more advanced training that I'm doing. And I don't know whether I really want to actually call this advanced training or not advanced training. Basically because this is some of the stuff that R actually does really, really well. And if you understand this, this actually becomes a kind of regular part of your workflow. But, you know, a lot of times, a lot of the R courses that I've seen around, you know, they start talking about things like vectors and lists and, you know, different things like that. And, you know, I think that it's not always completely obvious, how these kind of always fit into everything, even though they're such an integral part to the language. So when I came out with my R course, I basically focused on data frames because, you know, a lot of people coming from backgrounds using things like Excel and using things like databases, they're not really familiar with the concepts of vectors and lists quite so much. They're more so familiar with the concepts of tables. So let's start with a table, and, you know, coming from that perspective, it would be a lot easier to understand. But I'm going to try and I want to try and break this down so that, well, basically, you'll see how to do this and how you can do other cool stuff like this as well. So here, this is basically the count of unique items for every single item on here. And the reason why this is useful for, you know, for a dashboard purpose is that, well, this is the dynamic grouping, right? So if I change this to here, I can see that maybe this would make a good category because it doesn't have too many items, right? Now, department also works pretty well. That's going to go off and it's going to split this up. But you can see that, you know, when with some of these things, let's say like city or something like that, it's got 160 items. This is just not really going to render or display so well because the legend takes up the entire thing, right? And basically, if you just have too many categorical variables, it just makes no sense to actually visualize it this way. So even though R can process it, so in the background, you still got this crunching 5 million records in the background. It just doesn't visualize well. So that's a handy little thing to have there. Now, the reason why some of these other things work, like I've got, this is a base salary field. And so this is not a categorical field. This is a numeric field. It's a continuous variable. And so it renders differently on the chart. Now, in this little table down the bottom here, this is actually grouped it by every single unique base salary value. So this is this is actually perhaps a little strange, and so this will actually be turning a fair number. It's going to be returning 4,300 records here, right? But it's returning a lot more data, right? Again, not necessarily. I mean, you'd probably want to bin that, and that would make a lot more sense. But anyway, you got some interesting visualizations there, and you can see the kind of roughly the distribution of that. Okay. So the extra updates to this, these extra lines of code are, where are they? It's basically here. So this is the line. Now, let's make this, let me start with, I'm just going to use a clean console window. I'm just going to clear this using Control L. And let me see. Let me load up my data using data tables. Fread. Okay, so there's my data set there. All right. And if I wanted to get the unique values of a certain column, then I could basically use the function unique. Select my column. So let's say something like department. Okay, that needs to be in quotes, right? And it's picked out all the departments for me, right? So let's, if you wanted to effectively get the count of that, it would be the same thing, right? But now let's put that inside of length, right? And now we have 30, we can see we have 31 items. Okay, so that's kind of handy, but we've only done it for one column. What we really want to do is be able to do this for all of the columns all at the same time, right? That would be kind of cool, right? So we've got a data set, and I'm going to use the function map. And I'm going to talk a bit more about this in a sec. But effectively what this is going to do, this is going to iterate over every column, right? So it's going to iterate over every column. And again, effectively what we're going to do is get this, right? Stick it in here, right? And instead of specifying a certain department, I'm just going to say .x, right? And I'll go over this in a bit more detail another time, but basically .x is the kind of syntax for this particular function here, right? And it's just giving me all of those. If I wanted to do that in a slightly more simplified kind of view, to make this slightly easier to see. Yeah, there we go. So then now I can kind of see it in one line, right? So there we have, so df is short for data frame. So this returns all the values back, and it's just performed this function for every single column, right? So really pretty powerful, really pretty cool. So you can start to imagine, if you will, like all the different applications of this. You could use it to, I don't know, say do a data quality check on every single one of your columns with one line of code. You could use this to, basically slice up your data, maybe run a bunch of different reports, all kinds of different things. Now, one of the things I wanted to do is come up with some training that would help with the intuition of how this function actually works. And well, actually, just to get a feel, actually, does anybody here use the map functions in R already? Be good to see. Just pop a little message in the chat. It'd be great to know. Okay, and while it's doing that, I just want to load up. Cool. Cool, so not really. So map is in base R. If you've used base R, actually I don't know. Let me know if any of you have used kind of much base R before. But these are sort of equivalent to the apply functions in base R. But the map functions is basically the tidyverse version of this, and it has a number of benefits to it. As usual. But a very, very, very powerful function. Okay. Now, to understand this, what you really need to understand is, well, vectors and lists. And I noticed that a lot of different lectures kind of explain this in a very, there's a lot of theory, and you can't really see how you can necessarily apply it to so many things, right? So what is a list? What is a vector? Why is it actually really important? Well, let's go back again to talking about data frames, right? So in Excel, here we kind of have a table. Actually, this is not a table. So in Excel, I don't know if you know, but there's actually 5 different types of tables. So I'm just going to talk about 2 of them here, and I'm going to save talking about the other kind of 3 of them for like another time. But this is actually a sheet. So this is, like over 30 years ago when Excel came out, and it came out with a spreadsheet model. It was all based on sheets, which you could like kind of stick anything anywhere you want. And it didn't really have much form to it, right? I'm going to come over to my data here, and I'm just going to hit the Control T button to basically turn this into a table. Now, this is a feature that came out in Excel 2007. Right. And what this does is it basically adds a lot more structure to our data, right? So instead of just having these kind of random, like A2 to like B5 kind of ranges, you actually have named columns, which is actually a pretty handy thing, right? And so you have a name table, and you have columns with names, and each of the columns, has a single type of data. And this is kind of the concept of tidy data, right? Which is effectively the data, the type of format and structure we need to work to do data analysis, right? So now in R, this is equivalent of a data frame. But in R, the data frame is actually composed of different bits as well. So a vector is basically a one-dimensional range. So every column in a data frame is a vector, right? So this is a vector, this is a vector, this is a vector, right? Every single one of these is a vector. Now there's certain rules for a vector. A vector can only contain a single type of data. And so, basically it's simple types like, characters and numbers, and true false values, Boolean values, that sort of thing, right? When you want to start mixing up the different types or having more complex types, that's what a list is. So a list is basically a special type of vector. So again, it's like a one-dimensional range, but instead of being able to contain just simple types of data, it contains complex types of data, including other vectors, right, and other lists. So technically, a data frame is actually a list, so that's your list up the top there, populated with lots of vectors, right? So that's what a data frame is. So, and here's one of the things. Here's one of the reasons why R is so good and so powerful for data analysis versus, say, any other programming language. Basically, R is natively vectorized. And what does that mean exactly? In any other kind of programming language, your basic type would be, like a single numeric value, like a single integer or a single character field, or something like that. Well, not even a field, just a single, like a string, basically, right? A single value. Whereas with R, right, the most kind of fundamental basic building block type is already vector, right? So, if you want a single value, it's basically a vector with one element in it, right? But a lot of times you're working with more. And the implication of that is that every single thing in R is basically built to work on vectors. So, you're not having to write loops, right? In a lot of programming languages, you need to loop through things. I mean, in Excel, you would create a formula and you would fill it down, right? And it would, copy that formula over and over and over again, or perform that formula over and over again, right? I mean, the more sophisticated way of doing that is writing some sort of for loop, something like that. If you've done any programming, that would be kind of familiar. But in R, you kind of don't really need to do that, right? Because all the functions are made to work over vectors, or, so that they are more slightly complex counterpart, the list, right? And so this is what the map function does, right? It basically iterates over lists. Okay. Let me give you a few more examples of this back into R. Let me clear this out. And by the way, let me know if you're finding this kind of helpful, if this is kind of making sense, right? So this data set here is the data set we're just looking at is the MPG data set. So here we have a copy over here. And one of the things I was mentioning before is that lists can contain more complex data sets, right? So one of the things with Excel is that, the problem with cells effectively is that they can only contain like a single value, right? So they can't really grow or shrink or anything like that, right? You write a formula in a cell and it basically does some summarization or whatever, and it has to pull back the values for a single cell. And if you want something to work in multiple cells, you basically need to copy that formula into multiple cells, which means if you don't know how big the output range is before you write your formula, then you got a little bit of a problem because your thing can't adapt, right? So in R, that's not really going to be a problem. Like we saw before, we can see the unique, we use the unique formula to get all the unique values, right? So I could just go unique and so MPG, bracket, manufacturer. Okay. And here's another little slight difference between tidyverse tables and data tables, which I was illustrating before, is that it automatically puts these quote marks in for me, which is kind of handy. So there we go. And it's got the unique values there. By the way, just want to check in as well. I haven't really talked about this, but does everybody know what these kind of square bracket kind of notations are? Because I haven't really talked about or covered these too much in my courses just yet. There's a few ways that you can kind of do this, actually. I mean, you can do this. A lot of times what you see is something like this kind of notation instead. This is, in base R anyway, this methodology here, it doesn't do exact matches. It actually works on partial matches. So that's something that people aren't familiar with. So if you have two kind of similar column names, then, it's actually not as safe as doing this. The other thing is here, because that's effectively a string, you can make stuff dynamic by, putting different, like putting a string variable in there instead, right? And you can do stuff like that. So this is the preferred method to this, right? But this is also very common for effectively picking out columns, right? Okay. So, where was I? Now, let's say I wanted to do something like, here's something that people wanted to do all the time, actually. I want to chop up and create a bunch of reports, right, for every single one of these unique manufacturers, right? So, typically if you were going off and you were using some VBA or something like that, maybe you get all the unique values and then, loop through each of these unique values and then do a filter on your data to do all that kind of stuff like that. But, it would be a much kind of longer winded process. Whereas with R, what we can do is we could say, get this data set and let's pipe this into, say, nest. Nest. Yep, there we go. And let's say minus manufacturer, right? Let me just assign that to something. So let's call this DT. Okay. Right. So now if I look at DT, right, we can see we have a table here, right, which has the manufacturer down the side here, and it's got a list here. So this is my character vector column here, and this is my list column here, right? And basically every single one of these contains a whole extra table inside of it, right? So that's kind of cool. So it's not just simple data types, you've got an entire table. So if I took a look at that, say view DT, you can see you've got this here, and you've actually got a table. You can actually click into these as well. So I can come over here, and oh look, there's all my data, right? So pretty neat. Cool. So let's come back over here. So let's say I wanted to do something like generate a CSV file for every single one of these. Well, have we seen this is a okay, well that's a list. Okay, so you could kind of go through all those, but I want to pick out this name over here. So I could take my nested data frame, and what I'm going to do is I'm going to use a function. There's a bunch of functions I could use, right? So I'm going to use a function called pmap. Okay. Now, I used the map function earlier, and this is the pmap function. Basically, what this does is it's short for parallel map, right? And it sounds kind of complicated, but basically, you can normally lists maybe just have like a single. Normally, you're just working with like a single list in a vector, right? But this time, what we're going to do is we're going to work with effectively two vectors, right? And remember, a list is a more complex vector. So we're going to use this to apply the effectively the report name, right? And this this one over here as the data that we want to output. Okay. So here I'm going to create a function, and I'm going to pass in manufacturer and data. And what I'm going to do is I'm just going to go write CSV. And this will need my data, which is data, and it will need a path. So I'm going to write this out to a folder called test. So this is a folder I set up earlier. Let me just find that and share that to you. Okay, so this is my empty test folder over here, right? So I'm gonna write out test, and I want to get the manufacturer name. So actually what I want to do with this is wrap this in a paste function. Paste 0 is basically concatenate with no delimiters, so everything gets bumped up nice and close to each other. So I'm going to use manufacturer in there and .csv. Okay. Let's run that. Did I miss a bracket? Okay. Anyway, you can see that that's done, and that took about 1 second to create 15 reports. Right. So, you know, pretty kind of cool. Now this is outputting CSV files, but you could just as easily do this with something like a Flex dashboard, right? So a Flex dashboard is just a R Markdown report, and this is one of the things actually. So with Flex dashboards, and this is one of the key reasons why Flex dashboards are, I believe, a much better option than actually Shiny on its own, because Shiny is not based on R Markdown. It's actually based on Shiny functions, right? So if you take away your Shiny server, which a lot of the times you don't necessarily have, right? You don't always have the luxury of setting up a Shiny server. Then Flex dashboards work standalone, right? They'll just generate an HTML file, which you can just email to somebody, and they can just double click it and open it up in a browser, right? So that's pretty cool, right? If you could like generate all your reports just like this, and that's basically one line of code, right? One little tiny line of code, and all you're doing is passing it into the R Markdown render function instead of passing it into write.csv, right? So I think that's one of the things that I'm gonna look to kind of teach as well. So I'm working on some lectures to kind of go over that, so you can do all this kind of cool stuff, right? But yeah, very powerful stuff. Okay, and besides writing out reports, I mean, effectively, you could do anything with this, right? So let me kind of bring this back again. Let's say I wanted to do something like, I wanted to get, say, a summary on every single one of these tables, right? Well, you could actually do that pretty easily as well, right? So what was my data set again? So this is DT and data. Map summary. Yep. Quotation marks. Right? And this is just created a summary for every single table for every single manufacturer, right? So there's there's 15 of these summary files. So this is basically all of the summary statistics, right? Again, with like almost no code, right? So there we go. Cool. So, I mean, I could kind of go on and on, but I mean, that's the, so what I'm planning to do is almost kind of create a little bit of like a recipe book for like all of the kind of most common things that you would actually want to do with this. If you have any ideas as well, hey, let me know some of the things that you're doing. I mean, the kind of easy candidates, like if you do any programming right now and if you're writing any loops, right? Could you put those summaries into a data frame? Yeah, absolutely. So basically, this summary has returned a list, and you could actually take this and turn it into a column inside a data frame as well. So if you wanted to do that, I would just go dt mutate and summary equals to that. Yep. Apply that back to DT. Okay, so now there's my summary inside the data frame, right? So let's take a look. There. It doesn't really kind of read so well there, but you can actually, right? And this is the kind of cool thing. I mean, this is one of Hadley's things actually, that he puts entire models into each one of these kind of list items, right? And this is how basically he organizes his stuff, right? He'll take up his data set and then he'll split it by whatever he wants to run, like a regression model against or something like that. And he'll take the entire output from that regression model and put it into one of these items, and then kind of do a summary of the entire thing, right? So really, really powerful stuff. Very, 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 very cool. So yeah, wow. It's that's kind of, that's what I think as well. So it is very, very cool stuff. Okay. Anyway, this is just some of the stuff I've been working on. And yeah, I mean, originally I was just going to show you how, some of these dashboards and stuff like that can actually handle much bigger data sets. So you got the little hack using data tables and stuff as well. And while I'm on that, I might as well just take a minute just to explain why I don't use data tables quite so much. Like even though that it's faster, so I mean I already mentioned that the data table format is not as interpretable as the tidyverse format. So that's kind of one key thing. It's much easier to work with tidyverse because when you get into things like tidyverse is not just data tables were effectively like a fast base R data frame, and they did a lot of tidying up and everything as well, right? Now the reason why I definitely don't use base R is because, well, like I said, it was used for teaching over 20 years ago. Data wasn't really very big back then, right? So you've got all these different issues like characters importing as factors. What's the problem with that? Factors aren't actually text, they're actually numbers, right? And so that's an important thing that you need to take into consideration. But you do want to use that in certain situations. You want to use that for building certain models. You want to use that for piping through certain formulas. So there is a time to introduce that, but you have to introduce it at the right time. So if you using base R data frames and you're working with a large data set and you accidentally type it in and print it out to console, you could basically hang your computer for like 10 minutes while your data is just printing, right? Which is kind of crazy, right? This is why data tables and tibbles, as part of tidyverse, they'll print out the summary for you, and so you can't ever accidentally do that, right? But then you can always go into the detail as well if you need to. What are some of the other things? Data tables, they don't include the kind of grouping feature that tibbles do, right? So that's one thing there. And there's a bit of namespace conflicts and stuff as well. I mean, data table is almost such a generic kind of name. You might have even got confused between where's my dashboard again? So this down here is data tables JS, right? Which is completely different from our data tables, right? So our data tables is a fast in-memory data structure, which is equivalent of a data frame, whereas JavaScript data tables is this JavaScript visualization, which is just meant for output, right? And because these things have the same names, there's a bit of namespace conflicts. I mean, it seems kind of silly, but anyway, there you go. That's one of the reasons, because it's really confusing to use two different libraries, both called data tables. There's also some overlaps in the functions and everything as well. So if you're using both of them, you have to be careful about when you call a function, basically, and two libraries have the same function, you load both of them, one will override the other, right? And so this is something you have to be careful with. And which one are you actually calling when you call the function? So you don't really want to kind of think about those kind of things. And for the vast majority of the time, tibbles are going to be plenty fast, right? They are still a very, very fast data structure. So by default, use tibbles, right? If you want a quick hack to speed things up, if you're using big data or bigger data, use data tables. I mean, this is still technically not big data, because once you go into big data, you're going into big data infrastructure, and you're not going to be processing that on your computer anyway, right? And that's a completely different story. But then again, you can still use tidyverse for all of that, because you've got database drivers that plug into big data sources like Spark and different things like that, right? So, cool. Anyways, so yeah, I think I'm going to probably just call it there for today. But hey, if you have any other questions or thoughts, hey, just please do let me know. If you haven't downloaded the code for this yet, there is a link in the YouTube video where you can go ahead and do that. And then you'll get sort of notifications and updates as well about when I'm coming out with some more of this training. So anyways, I hope that helped, and I will see you guys later.